and alkynes, and we'll get to aromatics at the end of this chapter. We talked about the double bond, and we said that the double bond kind of fixes the shape of the molecule. You cannot rotate around the double bond the way you can rotate around single bonds. There's no rotation there. All right, so already you see it's different. It's different from a single bond. So now we're going to introduce geometric isomers, just different geometries. And if I said we had a compound called 2-butene. All right? 2-butene. Now, well, let me just back up a second here. You should think of this double bond having this kind of geometry around it. When you think of a carbon-carbon double bond, you should think that there are going to be two things coming off of each carbon at an angle. It would be like this. Now, with what you know so far, you'd say, okay, but, 4 carbons, right? So you go here, 4 carbons, ene, there's a double bond. It starts on the second carbon. So you'd think of something like that. And then you might say, okay, let's see, that's going to have 3 hydrogens on it. How many hydrogens am I going to put here? 1. How many hydrogens am I going to put here? 1. All right, so from chapter 10, you were in the habit of coming across here and slapping hydrogens on the top and the bottom of every carbon. You can't do that with double bonds. Triple bonds, you gotta count the bonds. We always want only 4 bonds, and 4 bonds. You don't want less than that. So we got 1, 2, 3, 4. You count those twice. All right, now, given this kind of geometry around there, I could have this. Think of that geometry. I could have this. I'm going to put those two up there. These are both 2-butene. Do those things need different names? Well, let's figure that out. Here's one of them, one on the bottom. I'm going to take a hydrogen off of here. And here's the other one. Are these different compounds? Okay. Remember what I said, if we can superimpose them on one another, then they're not different, they're identical. And you can see that here's the one where they're both going up. Here's the one where one goes up and one comes down. And remember I said you can't rotate around this bond. So I can't just flip that one down there up to there. Can't do that. Why? Because that doesn't move. That's rigid. Because that's rigid, this is not superimposable on that. When I do that, this hydrogen falls where the methyl is, the methyl falls where the hydrogen is. They're not superimposable on one another. So they are actually two distinctly different compounds. Both have the name 2-butene. So they are geometric. They have different geometries. They just differ in geometry. This goes up. The methyls are on the same side of the double bond. The hydrogens are on the same side, the bottom side of the double bond. Here, the methyl is across from. All right? When you make a phone call from New York to London, it's a transatlantic phone call across the Atlantic. This is trans. This methyl group is across from this methyl group. Trans. Cis, remember cis, well no, cis, iso means same, cis means same. Cis, same side of the double bond. So these are two different compounds. I would call that one trans 2-butene and this one cis 2-butene. Right? So if I look at the name of this compound, 2-butene, that is not sufficient to just call it 2-butene. Because then it raises the question, which 2-butene are you talking about? The cis or the trans? And this isn't trivial. I mean, there's a federal law going into effect here probably pretty soon. No trans fats in our food. No trans fats. No fatty acids that have trans double bonds in them. Because why? This is the kind of the geometry of fatty acids that are made in nature. Naturally occurring fatty acids. Unsaturated fatty acids are cis. They're not trans. Where does trans come from? Food processing. Hydrogenation of fatty acids. Isomerizes these bonds into these bonds. And you get trans fats. So trans fats are man-made. Cis fatty acids are human-made. And if people wonder, you know, what's going on with our food, why do I eat and don't feel right? Probably because of all the synthetic stuff that's in your food. Trans fats aren't. Okay, we'll get to that in chapter 17. I'm getting ahead of myself. But here we go, cis and trans. Now, what I need to do is explain a couple rules for you. You got to say, well, when do I need to put trans or cis in front of a molecule? And when don't I? Just because there's a double bond in a molecule doesn't mean there's going to be cis or trans in front of every name. So let's figure out, there's a couple rules you have to learn. So this is your poster child right here. If you think about cis and trans isomers, think of 2-butene. It's the simplest molecule to think about. And in terms of this, and you can see cis, it comes like this and goes like that. The methyls, and those aren't methyls. This isn't 2-methyl-ethene, it's butene. But there's a CH3 group on this side of the double bond and then another one on the other side of the double bond. And we'll go through these rules and you'll see how these satisfy the rules and would require us to use cis and trans. If the common group is on the same side of the pi bond, so a carbon-carbon double bond is sometimes referred to as a pi bond, just kind of looking at the molecular orbitals that are involved. If the common group is on the same side of the double bond, it's cis. If the common group is on the opposite side of the double bond, it's trans. This is the common group that is on both carbons. Each carbon has one of these. And they're on the opposite side of each other, so it's trans. Each one of these carbons have this group, and they're on the same side of the double bond, so it's cis. Okay, here are the rules. We're going to ask 3 questions, and if you get a yes for any one of the questions, you're done. You don't need cis or trans in the name. Okay? So we'll go down through and asking these 3 questions. If we ever get a yes answer, then we can just drop it and just go on. We won't use cis and trans in the name. First question. We look at the carbon here and we ask, does this carbon have 2 different groups on it? Let's see. Yes. If no, continue. Yeah, so if you get a yes answer, wait a minute, I get myself confused. If you get are both groups on the double bond the same? No, okay, it's the way they're asking the question. Are both groups the same? No. So you continue. Is one group on each carbon the same? Yes. Okay, maybe I ask these questions differently. I'm sorry. Let me back up. And does this carbon have 2 different things on it? Yes. Does this carbon have 2 different things on it? Yes. Do these 2 carbons each have something on them that is the same? Yes. Okay, so we get 3 yeses to all those questions. Then we have cis and trans. Does this carbon have 2 different things on it? Yes. Hydrogen is different from that. Yes. Does this carbon have 2 different things on it? Yes, that is different from that. And do these 2 carbons that make up the double bond have something that is the same? Yes. They each have a CH3 on them. So this is going to be cis or trans. Let me just draw another quick molecule here and show you how. Let's say we had any time you would have this situation. Let's start right here. And so we would look at this molecule and we'd say, does that carbon have 2 different things on it? No. No. So it is not cis or trans. Anytime either one of these carbons have 2 things that are the same on them, there's not going to be cis or trans. Let me give you another quick example. Let's say we had this molecule. And I'd come over here and I'd say, does that carbon have 2 different things on it? Yes. Does this carbon have 2 different things on it? No. That CH2, CH3 group, CH2, CH3, CH2, CH3, they're the same. So it's not cis or trans. All right? you're not going to need to use cis or trans in the name. If you ever have either one of these carbons that have identical things on them. So let's go back through here. So we're looking at here. Is A and B different? Yes. Is C and D different? Yes. Is there something that's the same? Yeah, A and C are the same. Yes. So this is going to be cis or trans. And in this particular case, it would be cis. Because the thing that is the same is on the same side of the double bond. So it's going to be cis. Okay, let's... And so, yeah, so they're saying now they're not going to call these methyls here. They're going to look for the longest chain. 1, 2, 3, 4, 5. There's your longest chain. So it's going to be pentene. And the only thing we didn't put on there was this, and it's on 1, 2, 3. It's on the third carbon. Oh, before we go any further, it's 2 pentene, right? This is carbon 1, 2, 3, 4, 5. So it's 2 pentene. It's 3 methyl 2 pentene. And because these two things that are the same are on the same side, it's going to be cis 3 methyl 2 pentene. All right? If you haven't gotten that yet, I can understand. It's the first time you ever heard of cis and trans. All right? And now we're putting cis and trans in there. Let's go on. Let's look at a few more. Let's just kind of go through these rules now and figure out whether these are going to be cis or trans or not going to be cis or trans at all. Okay, so let's come on over here. Does that have 2 different things on it? Yes. That carbon. Does that carbon have 2 different things on it? Is that different from that? Yes. Do these 2 carbons have something that is the same? Yes. This one has this, and they each have a methyl. And the thing that is the same, where is it? On the same side or across from? So is this one here going to be cis or trans? Trans. Let's not worry about naming it, just identifying it. It's trans something. Okay, let's go to B. Does this carbon have 2 different things on it? Yes. Does this carbon have 2 different things on it? No. Those are isopropyls right there. One of them is an isopropyl. One of them is going to be part of the longest chain. Okay? But they are the same. So, neither cis or trans. Okay, how about here? 2 different things on it? Yes. 2 different things on this? Yes. Is there something that's the same? Yes. Actually, there's 2 things. That is the same as that. That is the same as that. The things that are the they in the same side or the opposite side of the double bond? Same, so it is cis. All right? So we got trans, we got a neither, and a cis. You could go back and name those. Okay, now look over here. Here's a molecule. We got chlorines here. Does that have 2 different things on it? Yes. Does that have 2 different things on it? Yes. Do these two have something that's the same? Yes. And they are on the opposite side. So this is trans. Let's go ahead and name this one. This one is going to be trans. Ignore that up there. Okay. All right. So to name it, 1, 2, 3, 4. That means it's butene. It is 1 butene. The double bond is starting on the first carbon. It's a dichloro. It's 1, 2 dichloro. 1 butene. And we already figured that out to begin with. It's trans. All right, that answers the question. Where are these chlorines? They're on the first and second carbon. There's a chlorine on each of the double bonds. Where are they? Well, they're on the opposite side of that double bond. They're trans to one another. And that's trans 1, 2 dichloro. So we can take it off of there. Trans 1, 2 dichloro 1 butene. All right? Okay, there you go. Draw a couple of these. Draw cis 3-hexene and trans 3-hexene. Draw them. Cis 3-hexene and trans 3-hexene. Let me just repeat what I said before. Whenever you have a double bond, you should have that around it. Don't ever draw these now like this. Some students like to do this, and then they put a hydrogen here and a hydrogen up there, saying, oh, that's trans. Well, what I like to see, if that's what you want to do, is put a hydrogen up here and put a hydrogen down here and put the rest of the molecule coming off at an angle. Now, once you get over to here, if you want to continue on in a straight line, that's fine. But don't have a straight line around a double bond. Break that straight line and go into this configuration of things coming off at an angle. Gail. Where's Gail? Right there. Sarah. Matthew. Chelsea. Francesca. Let's see. hexene. Vanessa. Where's Vanessa? Alejandra. Adam. Danielle. Kimberly. Catherine. Brianna. Mackenzie. Chelsea. I got Damaris. And Samantha. Okay. All right. Okay, cis. So cis 3-hexene. So what I would do, I would, there's where it would start, right there. And it's cis, so same side. So the double bond starting on carbon number 3. 1, 2, 3. 4, 1, 2, 3, 4. 5. Why do I go up there? Because it's cis. It's going to have a hydrogen here and a hydrogen here on the same side of the double bond. 5, 6, 6. There we go. Cis 2-hexene. Or excuse me, cis 3-hexene. Okay, now, before we go on to the other one here, let's just do a line formula. There's the line formula. That's cis. 3-hexene. 1, 2, 3, 4, 5, 6. Once you can draw these straight here in the structural formula, but in a line formula you do have to show a bend every time you get to a new carbon, right? And around the double bond, I want cis to look cis. There should be something coming out of the same side of the double bond. Now let's do trans.
Professor, question. In the line for the double bond, do we have to put it under or above the other line, or is it the same?
It doesn't matter. I mean, if it was like that, that would be fine too.
Okay.
Just 2 lines there. Your double bond.
Thank you.
Okay, trans. So I start with my double bond. I'm not doing a line. I want to start with my double bond. And since it's trans, I got to come out of the other side of that double bond. Sorry about that. Thought I had this turned off. So that would be your trans. Is that right? Trans 3-hexene. So now the line formula. Double bond. So if I got a trans, I'm going to have a double bond, and I want to see that around that double bond in the line formula. Comes in one side of the double bond, goes out the opposite side. So trans should look trans. Cis should look cis. Yeah, this is where I said some students on the structural formula, they might draw it like this. And they say, oh, it's cis, so I'm going to have a hydrogen here and a hydrogen here. The hydrogens are on the same side of the double bond. Yeah, but I like to see the whole thing being cis. I like to see it like this. All right? So always think of this configuration around a double bond, which is, you know, what you have here. That's the configuration you're going to have around a double bond. Things are going to be coming out at an angle. All right. Yes.
I have a question in 15. What if we had a 3-octane? Like right now it's like horizontal and then down.
So which one you want, cis or trans?
Cis, but octane. Because I want to know where the next line will go, either up or horizontal.
Cis 3-octene.
Yes.
There's 6, 7, 8.
Oh,
Right?
so the rest, like from the carbon with the double bond, it's going to go up. And then from there, it's going to go linear.
In a structural formula, that's your structure. But in the line, you got that? That's 1, 2, 3, 4, 5, 6, 7, 8. You keep bending. You just put a bend in it after every carbon. Yes?
So cis doesn't really mean that they have to have the same exact, like that one has like 4 C's and then this side is 2.
No, it doesn't. Cis means here's what's cis in this case. That's the thing that's common.
Okay, so
What's common is 2 hydrogens right there. Yeah, so that's what's common right there. Yeah, okay. Did I see another hand over here?
I was going to ask, on the homework, are you going to want us to put the hydrogens on the carbons? Because on the examples you're not.
Yes, I want you to put the hydrogens. For chapter 10 and 11, I want to see every hydrogen. I started grading the quiz. I didn't get it all done. I got the one side, and I'm looking for hydrogens. So to mention the quiz, you had something that's 1,2 dimethyl. I don't want to bum anybody out. Cyclohexane. But for example, so if you thought of cyclohexane and you know that you got a hydrogen on every one of these carbons, 2 hydrogens. So here's a methyl. So yeah, I do want to see all the hydrogens. And there's a methyl on carbon number 2. Now what else do I need on that molecule? Need a hydrogen right here. All right, because each one of these carbons has 2 things on it, hydrogens. You take one of the hydrogens off and put a methyl, you still got 1 hydrogen there. You need 4 bonds around every carbon. So in chapter 10 and 11, yeah, do that. Later on, we might start, it might be obvious. I start drawing something, and I say, okay, those are all hydrogens, and we've got a chlorine right here. And I start ignoring that. But for right now, we're not going to ignore that. And not until you prove to me you know where the hydrogens need to be. Let's just leave that. There's a slide. Sometimes if we pass over a slide like this, you come back and do that. It's good practice, okay? And then if you're not sure, you can ask. Let's take one of these. Let's just pick one out. Go ahead and draw that. cis 1-chloro-2-pentene. Yeah, that one's going to be a little funny. So cis 1-chloro-2-pentene. I'm kind of curious how this one's going to work out myself. So here's pentene. Oh, okay. That works out fine. Yeah. You have something like that? Cis 1-chloro, yes.
I put the chloro on top and the 2 hydrogens on the...
That's fine.
Okay.
Okay, because Alejandra, I mean, if you did that, if you had that situation there, see, it doesn't matter where you put it,
Oh, okay.
it can rotate around and go anywhere.
Oh,
All right? It's structurally, it hasn't changed its structure by just rotating. So it can be down on the bottom and the 2 hydrogens on the top. It could be on the top and the 2 hydrogens on the bottom. It's all the same. It's got to be on the right carbon, the number 1 carbon. So that's why, you know, you guys can turn in your homework and you say, I didn't write it exactly the way she did, but we both got them right. You know, which one's right? Well, I'm looking for, is it on the right carbon? If it's cis or trans, if it's cis, then it's got to not only be on the right carbon, it's got to be in the right position on the right carbon. But here, the position doesn't matter because the position can change. It can structurally change. So any way you drew it there would be fine. Okay. Oh, what I have up here, in this corner is this one. And notice they give you the name there, 2-methyl-2-hexene, and there's no cis or trans in front of it. Why? Because this carbon has 2 of the same thing on it. It's 2-methyl-2-hexene. So the 2-hexene, we're going to have a CH3, and then we're going to get to the double bond. That's the number 2, 3, 4, 5, 6. But there's also a methyl on carbon number 2. So that puts 2 groups on carbon number 2 that are the same. And it ends up without having cis or trans in the name. This one, there's nothing here. It's not cis or trans. Doesn't need to be. Okay. Let's see. Let's go through alkenes in nature. And then I think we'll start getting to aromatics. Oh, no, we'll get to reactions. 4-addition reaction of alkenes. Very, very important. Really important. It'll be on the exam Friday. It'll be on the final exam. Alkenes in nature. Isoprenoids. this is not cholesterol. There's mentioning cholesterol, but this is a building block. This is a precursor. This is a molecule that your body can use to then start making cholesterol out of it. And you say, well, why would the body want to make cholesterol? It does want to make cholesterol. It needs cholesterol. We hear so much about it because we have too much of it or the wrong kind of cholesterol. But you can't survive without cholesterol. It's in your cell membranes. So this is 1,3. It's 2-methyl-1,3-butadiene. This is a butadiene. 4 carbons. I actually think this is the molecule that if they tap rubber plants, this is what they get out of rubber plants. And they make rubber for automobile tires and all kind of rubber things out of this butadiene. This is a naturally occurring alkene. Oh, there's more. There's more naturally occurring alkenes in nature, fatty acids. Unsaturated. I don't know why I don't have a slide on this. So, oleic acid that's in olive oil has a double bond in it. And then it goes off to a bunch of whole carbons. And why are they fatty acids? Well, you get off to a carboxylic acid on the end of it. It's an unsaturated fatty acid. Why is it unsaturated? It has a double bond in it. And they are cis fatty acids that you find in nature. Okay, addition reactions. Addition. And we're going to, maybe I'll write it on the board and on the slides. You're going to want to capture these 4. They have a particular name. Four addition reactions. I'll try to get them on the slide so if you listen to this, I'll tell you what I'm going to do.